Imagine the universe's biggest fireworks show. A star 100 times bigger than our sun exploding in a supernova blast that outshines an entire galaxy for weeks. That's how black holes are born, not with a whimper, but with a cosmic bang. Today, we're demystifying black holes, gravity's ultimate trapdoors where not even light can escape. Stick around for the wild journey from stellar life to death, mind-blowing facts and proof we've actually seen these monsters. If you're ready to have your brain warped by space-time, let's dive in. Stars are the universe's power plants, fusing hydrogen into helium like a non-stop nuclear furnace to fight off gravity's squeeze. Our sun is a pretty small star for the universe's standards. It is a middling yellow dwarf will puff up into a red giant in about 5 billion years, swallow Earth like a snack, and fade into a white dwarf. But massive stars, those behemoths 20 to 100 times the sun's mass, live fast and die hard, burning through fuel in mere millions of years. They crank up the heat, forging heavier elements, carbon for diamonds, oxygen for breathing, gold for bling, all the way to iron in their cores. Iron's the tipping point because fusing it sucks energy instead of releasing it, like flipping a switch from profit to loss. When fusion stalls, gravity takes over like an unbeatable wrestler pinning its opponent. The star's core, about 1.4 times the sun's mass, implodes in a fraction of a second. Picture a skyscraper collapsing floor by floor, but 1,000,000 times faster and denser. The outer layers rebound in a supernova shockwave, blasting material into space at 10% light speed, seeding new stars and planets. But the core? It crushes down relentlessly. Protons and electrons smash together into neutrons, denser than atomic nuclei. A teaspoon weighs billions of tons. If the core tops 3 solar masses, all pressure fails, and physics breaks. Gravity compresses it to a point of infinite density, the singularity, where space-time curvature goes infinite and our understanding of math and physics breaks completely. That's the black hole's heart, hidden behind the event horizon. The event horizon is not a surface, but a one-way boundary where escape velocity hits light speed. Think of it like a bottomless pit on a hill. Near the top, you can climb out with a jog. At the bottom, no amount of sprinting saves you. For a stellar black hole, 5 to 50 solar masses, the horizon is a few dozen miles wide, around the size of New York City. For 10 suns squeezed in, cross it and you're doomed. Light itself gets trapped, making the hole black. Time dilates too. From outside, you freeze at the horizon forever, redshifting to invisibility. But inside, you'll experience what is known as spaghettification. Gravitational forces will stretch you like cosmic spaghetti before crushing you at the singularity. Black holes come in flavors beyond stellar remnants. Supermassive beasts, millions to billions of solar masses, lurk in galaxy centers like Sagittarius A in the Milky Way, which has the mass of 4 million. Suns and a time horizon the time of a fist will likely form from mergers or direct collapse of giant gas clouds in the early universe. Primordial micro-black holes might speck the cosmos from Big Bang density fluctuations, evaporating via something called Hawking radiation quantum fizz near the horizon where particle pairs split. One falls in with negative energy, making the whole shrink over eons. Mergers ripple space-time with gravitational waves, detected by LIGO since 2015, 2 stellar holes smashing at light speed, birthing a bigger one and releasing sun masses of energy as ripples. For decades, scientists thought black holes were pure nonsense, but now we've got smoking gun evidence these aren't sci-fi. Cygnus X1, discovered in 1971, is a stellar black hole slurping gas from a nearby star, forming a hot disk glowing in X-rays with friction that heats it to millions of degrees. More recently, NASA's James Webb Telescope now spots supermassive black holes from 400 million years post-Big Bang, growing via quasar feasts that outshine galaxies. Gravity warps light from background stars, proving invisible mass monsters. No more doubt black holes are real, shaping galaxies by gobbling stars and flinging jets at 99% light speed. Want to level up your cosmic knowledge? These gravity titans challenge everything. Does info falling and vanish, violating quantum rules, the paradox? Can wormholes connect them to other universes? Primordial holes might explain dark matter. Upcoming missions like NASA's LISA will map mergers galaxy-wide. Black holes aren't destroyers. They're sculptors, forging elements, birthing stars via outflows, and testing Einstein's 1915 relativity, confirmed to billionths precision. Which black hole fact blew your mind the most? Tell me in the comments below. I read every one and reply to my favorites. If this warped your worldview, smash that subscribe button for more quick hit science, math, and history blasts every week. Turn on notifications so you never miss a video.